Right, this is chapter 4, part 3. All right, so we've seen our scatter diagrams and how to make them on the calculator. We've talked about the properties of linear correlation coefficient, those 8 properties for R. Now let's look at the linear relations between two variables. So what is this R value? How do we get it, first of all? And then how do we use it? All right, so in order to find the linear correlation coefficient, the first thing you're going to have to do is make sure that your calculator is set to show the R value when you do what we're about to do on the calculator. And to do that, you need to do second and the number 0. That gets you to the catalog. And then if you will press... let's see, it's the D button, but I think it's X inverse. It will take you down. You can just use the arrow button to scroll down, but it's a lot to scroll through. So if you hit I'm just trying to wait for my calculator to come up on my computer so I can see it. Yes, it's the X inverse button. That will take you to the beginning of the D's. And then you're going to scroll until you see diagnostic on, and then you're going to hit enter twice. Now you should only have to do this one time. So if you've already done this, because you saw that in the tech help for the My Labs Plus question help, if you go under tech help, it tells you how to do that as well. So if you've already done that, then you don't need to do it again. But if you end up doing what I'm about to do on the calculator and you only get 2 numbers and you don't get 4 numbers, then you need to do this step right here. Second 0 to open up the catalog, hit the X inverse button to help you get part way down the list, and then keep scrolling until you see diagnostic on. When you hit enter, it'll put it on the screen. You hit enter again, and then it should say done, and then you'll be good to go. All right, so once we have that part taken care of, then what we'll do, after you've got your diagnostic on set, then you're going to go to Stat and over to Calc, the Calc menu. Now, we've done this. We've been here because that's where we get our 1var stat. But we're not going to do 1var stat. Instead, we are going to do LinReg ax+b. So that is linear regression. And then our equation will be in the form of ax+b. So our slope times our variable plus our y-intercept. Now, if you scroll down a little bit, you'll see that number 8 is very similar. 8 says, put it up here, LinReg, but it says a plus bx. Now, if you end up using number 8 instead of number 4, and you don't switch your numbers around when you type them in, the A and the B, you're going to get every problem wrong. So please, please, please pay attention to the order that your equation wants you to get. Now, we're not doing the ax+b part right now. We just want the correlation value, the R value. But I just want to, and it doesn't matter if you pick 8 or 4 to get the R value. But I just wanted to point that out because when we get in just a video or 2 further in section 4.2, it will matter. All right, so that's our first step, is to go to Stat, go over to Calc. When we select number 4, of course, there at the top, it tells us we're doing linear regression, ax+b. It asks for your X list and your Y list. And then it says frequency list. Notice that I have my frequency list blank. Leave that blank. I believe in the first copy of the calculator sheet that I posted for chapter 4, I said to leave the frequency list 1. Well, that was incorrect. There's a different setting that we can do with linear regression that actually uses a hypothesis test. We're not going to try and do that part, but in that one, for whatever reason, frequency list is 1 instead of blank. So that's where that came from. I apologize. I did not think to go in and look until a student asked me why they couldn't make that a 1. So X list, Y list, that's your L1 and your L2. Store regression equation. So this can be blank for right now because all we want is R. But in a minute, after a while, when we get to that part, we will want to make sure that we have that. So right now I'm just going to say, let's leave that blank. I'll make that go away. And then we're going to hit calculate. When we do this, we're going to get all kinds of good information. So again, if you only have y equals ax plus b, and then an a equals and a b equals, if you're missing this r squared and r, so basically if yours looks like this right here, then you need to go in and you need to do these steps that I posted right here. You need to do that because that is the only reason that your r and r squared would not be showing. So if your screen only has a y equals, an a equals, and a b equals, then you're missing the most important part for right now, that linear correlation coefficient, which is r. So in order to get that r to show up, if you go in and turn those diagnostics on, then you should get the r squared and the r equals value. Now this is based on random data. This is not the data that I had in that we've been using on our example, and I will show you that data momentarily. This is just to see how we get that linear correlation coefficient. We've got a y equals ax plus b. That's just saying, that's the order that a and b go in. R squared is not something that we're really going to focus on very much, actually at all, I think, this semester. Usually, when it's face-to-face, I will talk about this r squared value, at least some, so that you have an understanding of just, why is it? What is it there for? What's it doing? What we care about is the r value. So this value right here, this is the one we're focusing on for this video. That r value is telling us how related our two variables are, and how strong that relationship is, what direction that relationship is, and that's very important just for one single number. That's great. All right, and then let's see here. If I do leave that y equals, so if I let this y equals go into the store reg EQ, regression equation, that's what that means. If I store the regression equation like I do right here, let me highlight that in yellow. Whoop, that's not highlighting. Let's try that again. Sorry. There we go, highlighter. So if I change this, all that does is now that I have that same graph I had before, but I have this line going through it. And so that'll be really handy for section 4.2. Okay, so determining whether or not we can say that there's a linear relationship or a linear correlation between our two variables depends on the value of our linear correlation coefficient. So what is R? But it also depends on the sample size. So the smaller sample I have, the more related I need my variables or my data to be. So for example, if I only have 3 data points, then I'm going to need a really, really strong or really high number for R. And that could either be positive or negative. So one thing to note is that we are comparing the absolute value of R to this value in the second column. Now, you may wonder, what about n equals 1? Why do I have n equals 3 as my first entry on this table? Well, if I have n equals 1, it means I have a sample of 1. So think about that. If I have a sample of size 1, if I have one data point, I can draw an infinite number of lines through that data point. I have nothing to help me understand the direction that I should be going. So, I've got all these lines that can go through this data point. Positive, negative, a 0. I don't know. Nothing can tell me. So I will never have a sample of size 1. But what about a sample of size 2? Well, there are two options, primarily. I either have 2 points in one of these two situations. And in both cases, a line is defined by 2 points. I can define any line by 2 points. So if I have exactly 2 points, then as soon as I have that, then boom, I can always draw a straight line through them, regardless. Ooh, that is not a straight line. Let me try that again. That's straighter. So there I have a straight line through those 2 points. So I will have exactly 1 or exactly -1 every single time if I were to take a sample of size 2. We would never just have a sample of size 2, at least not if we were actually trying to answer a question about something. So our absolute smallest that we could have is a sample of size 3 for us to be able to do this R value thing. So if we look back, what we just saw in our my completely made up data was an R of negative 0.31-ish. It was 30 something, 8 maybe, I don't know. But anyway, so that R of a negative 0.31. And so I want to look at the absolute value of R, which of course is going to be 0.31. And in order for us to say that there is a relationship, I need my R has to be bigger. So R must be bigger. Oh, let me change that. Absolute value of R must be bigger than this value, because I had 10 values in the made up data set that I had. So my R of 0.31, not big enough for 10 data values. Now I will have a complete table that you can have for the homework, because some of the problems include it and some don't. But I will give you that table under the content portion in Momentum. So you can look there for, it's just an Excel file that has the values for N and the R values going through, hopefully, anything that you would end up needing. Okay, so let's see if we can find a linear correlation, or see if there is a linear correlation by finding the linear correlation coefficient to see if there's a relationship between the depth at which drilling begins and the time it takes to dry drill a distance of 5 feet. We're going to use our calculators for this one. So again, no doing this by hand. Do not use the formulas, please. All right, so here's our data. Again, this is already in our calculator if you were following along with the previous video. So hopefully you have these. If not, go ahead and put them in now. All right, so of course, the first thing we want to do is go to Stat, over to Calc, choose that option number 4 for the LinReg ax+b. Again, L1, L2 frequency list should be blank. In this case, I'm only looking for the R value, so I'm going to leave that store reg EQ, store the regression equation. I'm not going to worry with putting that value in. And I'm going to hit calculate, and when I do that, I get all my wonderful data. Again, right now, I only care about one number. The only number I care about is this R value. And that looks pretty good. That's fairly close to 1. I mean, relatively speaking, it's closer to 1 than it is to 0. But of course, what we really want to be able to do is know, what are we comparing this to? Well, this was 12 data points, so we had an n equals 12 for our list. And so if we take a look, now I only put the row for 12 on here. And so when we look at that, we need our absolute value to be greater than 0.576. Well, sure enough, it looks like it is. We have an absolute value is the same as our R, and we have 0.773. So that is bigger. So what this means is what we can say, and I would say maybe, I would call that strong. I mean, 0.77, that's, like I said, that's much closer to 1 than it is to 0. So we might say that there is a strong, positive. It's positive because R is positive. Strong because it's close to 1. So a strong, positive, linear relationship between the depth before drilling and the time it takes to dry drill 5 feet. So it seems like the further down you start, the longer it takes. That's that positive relationship. The bigger X gets, the bigger Y gets. And when we get to our linear regression line, we'll talk more about how that, just how much longer it takes based on how much farther you are down.